All right, guys. So, in our last session, we were discussing about different test instruments and measuring instruments and about their measurement. That a good measurement should be accurate and precise. And we also discussed that the measurement should be taken multiple times to make sure that it is correct. When we take multiple readings, then we take the average of all the readings. Okay, so now in taking good quality measurement, there are some more factors which are involved, and we will discuss it in this topic. I will ask all of you to please enlarge your screen because the font might be small for you. So you can use the lens icon on top left corner. You can see there is a lens icon, and you can enlarge the document. So I have enlarged it for myself, and I will be going through this topic, which is about loading effect of measuring
Multimeter, when you
instrument.
enlarge it, you can see it. I believe
You can
so.
also see.
Oh, no, I'm mistaken. No. I'm using the tool, the left side tool.
All right, good. Okay. So the topic is about loading effect. So loading effect, in order to understand it, I will first read out the definition. It is the disturbance caused by the measuring instrument to the electrical properties of a circuit. Whenever you connect a test instrument to a circuit, it gives you some kind of reading. How does it give you reading? It gives you reading by using some power of the circuit. So if your meter is using a small amount of power from the circuit, it means it is actually disturbing that reading, that observation, that in measuring that parameter, if it depends on small amount of power being drawn from the circuit, so ultimately it will affect that correct measurement. So we have to live with it because there is no other way. The most common measuring instrument which you use in the lab is the multimeter. So when you use a multimeter and you connect it with a circuit and it shows you some voltage or current reading. So actually it is the current or the voltage, actually it is drawing some power, it is taking some power from the circuit. Ideally it should not take any power from the circuit, but in real world all the measuring instruments, they have to draw small amount of power. In drawing that power, you are actually, or the meter is actually disturbing that parameter under observation. So as I told you that we cannot avoid this, because in the real world there is no way that you can measure any parameter without disturbing the circuit. So what is the way out? What is the solution? The only solution is that you try to minimize this effect. You try to minimize the loading effect. So this is loading effect of the measuring instruments. If it is minimum, it means the test instrument is a good one, is good quality. So good manufacturer, they always make sure that the loading effect of their product is as minimum as possible. So ideally a measuring instrument is supposed to measure a particular quantity without drawing any power from the circuit under observation. I'm reading out this second paragraph. However, practically the instrument draw some power without which it cannot measure the quantity. So the yellow portion is the highlighted and important paragraphs, and I did it intentionally so that you pay more attention to these. Okay, loading effect of a voltmeter. Now we will discuss a couple of examples. Loading effect of voltmeter and loading effect of ammeter. Voltmeter, a meter which can measure volts. Ammeter is a meter which can measure current. Both of these parameters we can measure using a multimeter. We normally don't use a separate meter for voltage and separate for current. We use one meter which is called multimeter. The only difference which comes up is the way how you connect it. For voltmeter, guys, Abdurrahman, please stop this.
I'm sorry, teacher. I
You
got a
should,
video
yeah,
notification.
you should mute your mic.
I'm sorry. I thought my mic is muted. Okay.
So the multimeter, if you connect in parallel, then you can use it as a voltmeter and you can measure voltage. If you connect your multimeter in series, then you can use that meter to measure current. I hope you know because you have been using your meter in the labs for so many times. Anyway,
Multimeter,
so
easy, easy.
yeah, so the loading effect of multimeter, it says a voltmeter always connects in parallel to electronic component for measuring the voltage. We know that it's always connected in parallel. Voltmeter is built with a very high internal resistance. To reduce the loading effect, we want that voltmeter when it is connected in parallel, then actually it is giving a alternate way for current flow. So current will actually come out of the circuit and it will flow through the voltmeter. But if what we want that current drawn from the circuit should be as minimum as possible. So what is the way to do that? The way is that you keep the internal resistance of the voltmeter very high. So as you can see, it is written here, it is usually between 10 to 20 mega ohms, which is a big resistance, so that it draws minimum current from the circuit. Okay, but now there is a situation. This is we have taken our maximum precaution that we being a manufacturing company, for example, and we are making voltmeter, we try to keep the internal resistance of our voltmeter as high as possible so that when you connect it in parallel to the circuit for voltage measurement, due to its high resistance, it should only draw very little amount of current so that it is not loading the circuit and it is giving you the observation, the measurement as accurate as possible. But there is a situation which is written in the second paragraph of loading effect of voltmeter. But following situation might result in inaccurate measurement due to loading effect. What is that situation? When you connect a voltmeter to a very high resistance, the high resistance which is comparable to the internal resistance of the voltmeter. Internal, for example, internal resistance of our voltmeter is 10 mega ohms, and you connect it with the circuit which is having a resistance of 7.5 mega ohm. So 7.5 mega ohm and 10 mega ohm are close to each other and it's not much difference. So due to their parallel connection, the overall resistance of the circuit will change to 4.28 mega ohms. Now remember, the actual resistance of the circuit should be 7.5 mega ohm, but because you connected the voltmeter in parallel, and if you remember that rules to uh, solve the parallel circuit to find the total resistance. So after connecting the voltmeter, the total resistance will come out to be 4.28 mega ohms as written in this paragraph. So it means the meter has loaded the circuit, it has disturbed the circuit. Actually, the circuit was having 7.5 mega ohms, but due to connection of the voltmeter, its resistance changed to 4.28 mega ohms. So with this big change, the voltage measurement will not be accurate because it will not be a true reflection of the actual voltage of the circuit. So that is what loading effect sometimes happens if you are using voltmeter on a circuit with very large resistance. So we should take care, I mean, that the voltmeter resistance should be at least 10 times higher than the circuit resistance which you are measuring. So this was one example from the effect of loading effect of voltmeter. The last is loading effect of the ammeter, as you can see on the screen.
And that is current.
Yeah, the current. The ammeter connects in series. Whenever you measure current, you always connect the multimeter in series
And the
to
voltage in parallel?
yeah.
Okay.
So the ammeter connects in series to electronic components for measuring current flow in a circuit. Ammeter is built with very small internal resistance. Now remember, see, the voltmeter was built with a very high resistance because when you connect that in parallel, you are giving a additional path for current flow. You are giving one extra path for current flow out of the circuit. So in case of voltmeter, we keep resistance very high so that we don't want to draw much current from the circuit. But the ammeter case is different. In ammeter, you are connecting it in series to the circuit. So when it is in series, it means it is on the same line. And if you don't want to disturb that line, you would like to keep the ammeter resistance as low as possible so that it do not obstruct the current flow because you are connecting ammeter on the same line of the circuit. So the emitter resistance is kept very small in the range of 10 to 100 ohms. So it is preferably it should be only a few ohms, 10, 20 ohms like that. So that it offers minimum resistance to current flow because we want to disturb the circuit. We don't want loading effect. So a good manufacturer, we keep the emitter resistance very low. But there is a problem. What if you come across a circuit which is already very low resistance, which is comparable to the ammeter resistance? So the example says the ammeter internal resistance should be less than 100 ohms. But what if you connect it with a circuit whose own resistance is 50 ohms? Then what will happen? So it means the circuit internal resistance is 50 ohms and your ammeter internal resistance is also 50 ohms. So it will reduce the current flow. So ammeter will have a large loading effect. So it will give you a reading which will be inaccurate. So 50 ohms is stopping the current. If you add one more 50 ohm resistance in series in shape of ammeter, then it will reduce the current flow by half. So if you are getting, for example, 1 ampere, it means the actual reading should be 2 ampere, but your ammeter has loaded the circuit. So this only happens when you are using ammeter on a circuit whose resistance is very low. But usually the circuits have high resistance and ammeter should work fine. But if you come across a very low resistance circuit, you should consider this thing that your ammeter might cause loading effect. It might disturb the circuit and give you inaccurate result. So this was all about loading effect of the commonly used measuring instruments which we use in the lab, the multimeter in the shape of voltmeter and ammeter. Other instruments also have their loading effect. For example, the power meter, watt meter, oscilloscope, and other devices which we use for measurement, they also have their own uh, loading effect. But
Repeater.
yeah,
Oh, I'm gonna ask you what like in the voltmeter it gets high resistance, but
yeah,
a very high internal resistance, but like
yeah,
the ohms is low, is milli ohm, right? What is it called? MQ, M ohm.
Mega
It's
ohm.
milli
M
or
M M for
mega.
mega.
Sorry. Okay.
Yes.
Okay. Okay.
Small m
M
is
for.
milli. Capital M is mega.
Okay. I got
Mega
confused a
means
little bit. Okay. Sorry.
it's million. So always
Okay. Okay.
remember, guys. I saw many students doing this mistake. They don't differentiate between small m and capital M. Always remember, big M means big quantity. It is mega. Mega for million.
Mm-hmm.
Small m
All right.
means small quantity. So it is milli. Small m is milli, and milli is
All right.
1/1000. You know that. Okay. All
Okay.
right. So this was today's topic about the loading effect of the measuring instruments. I will stop the recording and open the forum for any question answers.